Okay, so now we are at the recording screen. Okay, so we will have a tutorial session for today's class. So this is a tutorial question. Okay, I hope you are already prepared for that. So let us understand this question first. Okay, if you need any more guidance, you need to stop me. Okay, so let's try to understand this. This is the three-span beam, okay, which is loaded overallly like a trapezoidal loading, 4 kilonewton per meter. But for each spans, you will see that for span AB, it is a triangular distributed loading, and for BC, it is a rectangular UDL, and for CD, again, it is a triangular. Okay, so given EI is constant throughout the beam, and E and I is not given a value, just tell you that it's constant. Therefore, later in your solution, we are going to just put EI. Okay, unless we have a specific value for this EI. And we need to know very well what is the answer request, okay, for the problem. Okay, because in this stiffness method, we can solve for many answers. We can solve for the displacement, we can solve for the support reactions, and we can solve for the internal forces like shear force and the bending moment at all the nodes. Okay, but now that is why, so we don't need to carry out all the solution for all the answer, only the required one. So now we want only the MB and also MC. That's all. Okay, so let's go through it and see the process on how. So first of all, we need to give where is the node, where is the element, near and far end, and prepared any and the DOF numbering, and prepared for the our target is to prepare this global stiffness equation. Okay, I hope you still remember this. Okay, so we are going to establish this stiffness equation at the end so that we can solve, okay, for the answer. So let's start with the notation. So if you look at this, let's use the same notation, okay, for our problem. Okay, we give a node at all the support. So there are 4 supports here, A, B, C, D. So the support node will be placed at node 1, 1 at A, 2 at B, 3 at C, and 4 at D. Okay, and in between the nodes we have an element. So in this case we have 3 elements, and then you need to assign an arrow, okay, for each of these elements along it, okay, to indicate the near end and the far end. Okay, and then we put in the DOF. Okay, in beam there are 2 DOF, which is this direction. Okay, so you need to place this and you need to remember this. The arrow point, the direction is a positive sign. Okay, indicate the positive sign of convention. So now you need to place this DOF at each of the node. Therefore, you have a total structure DOF is add numbers. Okay, so these add numbers also reflect your structure stiffness matrix later with the size of 8 times 8. Okay, so I think probably a more, not say difficult or tricky, but the one that we need to sort out is giving a numbering, okay, to this DOF. Okay, as what I have suggest to you. Okay, please refer to the support reaction. Okay, because these support reactions will be telling you, okay, the information where are the non-displacement, where the displacement equal to 0. Okay, let's try. So A, we have these support reactions, right? AX and AY. B, we have BY. Okay, C, we have CY. D, we have DY. So at this drawn direction, it also means the displacement is equal to 0. So I will just make it clear here. So AY is equal to 0. Okay, BY direction equal to 0. CY equal to 0. Okay, and DY equal to 0. Of course, the X direction also at A is equal to 0, but we don't giving a count here, okay, in the beam solution. Okay, so now you will know that this direction, okay, the DOF is all constraint. Constraint, or we said constraint means that it cannot move. Okay, constraint DOF, or we said this is already known. Okay, non-displacement. Okay, the displacement, these displacement are equal to 0. Unless there are, some value given to that supports, like support B has some uplift, has some tilted value, have some settlement, something like that. Okay. Then our rules to name the DOF, rules to name, label, number the DOF is first name the unknown DOF first, then the non-DOF. So you know that the circle arrow are all non-displacement. Okay, therefore this will be the unknown. 1, 2, 3, 4. You name it first. Okay, then only you name the remaining 5, 6, 7, 8. Are you clear, class?
Yes.
Do you have any question for this?
No.
Okay, if you want to start with this 1, 2, 3, 4, yeah, you can, no problem. Okay, but for this tutorial, just make sure you follow, so that we have a same answer later. Okay, you won't confuse throughout my explanation. So we will follow this. Okay, so I hope you already, sketch into your exercise book on this arrangement. Okay, so we will start the solution. Yeah? Okay, once you get this notation or labeling or numbering done, we can straight away get the load and displacement vectors. Okay, or so-called Q and D. Okay, you need to know that this Q is deal with the support reaction or loading at node. Okay, not at the element. Okay, loading at the element will park it at the for the Q node. Okay, so D will be the displacement, unknown or known. Okay, just now, which D are the unknown and which D are the known? Can you fill it in this, your vectors? Okay, can you tell me also here so that I can fill it? We will name it as D. Yes, D1.
D1 is D3, D4.
Okay, D1, D2, D3, D4 is unknown. We don't know the value. Okay, 5, 6, 7, 8 are all 0. Yes, thank you. So it is, this is how you fill in your D vector. Okay, remember we can do a partition. Okay, we can give a partition. Okay, to differentiate the unknown and the known state. And the unknown support reaction will be opposite. Okay, with this unknown displacement, it will be parked under here. Q5, Q6, 7, and 8. Okay, then you need to check lah. 5, 6, 7, 8, is that associated with the support reaction? Are they?
No.
The 5, 6, 7, 8, are they the support reaction?
Oh, yes.
Yes. No,
Yes,
no.
right.
Yes.
Yes, because 5 is associated with AY, 6 is BY, 7 is CY, and 8 is DY direction. Okay, so therefore you can name this support reaction as Q5, 6, 7, 8. How about Q1 to Q4? What is the value?
0.
0. Yes, because they are neither the support reactions direction, and there are no loading at that particular direction. Okay, unless there is like, for example, I'm just giving an example. For example, I have this 1 kilonewton meter. Then this one will have a value of 1 at this Q1. Okay, but now we don't have any loading at the nodes, okay, and no support reactions at this Q1 to 4, so they will be 0. Okay, have you written your answer to your exercise book?
Yes.
Okay,
Yes.
before we proceed, may I know who cannot see my screen? Anyone? Anyone? You need to let me know, so that if you cannot see that, I will post the answer step by step to your WhatsApp group. Anyone?
No, doctor.
Okay. Yeah, you can raise your hand or write to me, okay, if you cannot follow well. Okay, so next we will go to the next step. Okay. Yeah, you can start finding your Q node as well. The Q node is not the intermediate loading vector. I don't think it's the right way. Maybe I put in a fixed end reaction. It is also the loading vector, but due to maybe load vector due to, okay, intermediate loading. Intermediate loading, they will be more proper, or fixed end reaction, okay, because you are finding the fixed end reaction. Okay, so we are going to analyze element by element on this Q node. Okay, so here I have sketched the element number 1. So you need to put this element number 1, you take from A and B. Okay, and this is your fixed end. Okay, and then you put in the fixed end reaction just like in your appendix. Okay, so then you name this Q node. The Q node position for element 1 will be following this one. Are you okay, class? Okay, so why, maybe you will ask why this is Q1 node. Q1 node will be looking at this A at the the moment, okay, direction, and this will be Q2 node and so on. Okay, and then we have Q5 node and Q6 node about the vertical direction. So now please fill in the formula. Okay, let's try. For the moment, it will be deal with the Q1 node. Okay, and for MB, it will be deal with the Q2 node. Okay, so let us put this formula into the page. Okay, WL squared over 30. Okay, W is 4, the length is 12 meter, and divide by 30. So, okay, please find it. Okay, and Q2 node will be negative WL squared over 20. Okay, so it will be negative 4, the W is 4, the length is 12 squared over 20. Okay, so I will continue also for Q5 not. Okay, I will give you 2 minutes later to sort out your answer. Okay, 3WL over 20. I'm following this RA. Okay, so it will be 3 times 4 times the length 12 divided by 20. Okay, and Q6 naught will be on the RB, which is 7WL over.
Doctor,
Yes,
the L, the line for
12
an
meter.
element.
12 meter.
Oh, it's
This
not.
is 12 meter at 3 means that 3 times of 12 meter. Maybe
Oh, okay,
you can
okay.
put it like this, 12 meter, 12
All right.
meter.
Thank you, doctor.
Okay, so 7W will be 4, length 12, and 20. Okay, now I give you 2 to 3 minutes, okay, to sort this out. Okay, you let me know the answer later. Huh? If you are ready early, you let me know also. Done?
Yes.
Okay, can you let me know your Q1 note?
96 over 5.
19 point?
19.2.
19.2. Okay. And then Q2 note?
Negative 28.8.
28.8.
8.
Okay. So yeah, I just put it. Maybe I will use another pen. Again. Okay, and then Q5 note?
7.2.
7.2.
Okay, 7.2. And then Q6 note?
16.8.
16.8. Thank you very much. Okay, so we have done for this for element number 1. We need to quickly proceed with element number 2. Okay, so let's see. Okay, again, you draw all the information of element number 2, but now the UDL is 4 kilonewton per meter. Oops, I have put in the wrong appendix. Let me keep. Okay. My appendix. Let me search if I have. I have it here. Okay, so now the Q2 naught, Q3 naught will be WL squared over 12, and then Q6 naught, Q7 naught will be WL over 2. So make sure you know how to name this numbering. It just follow the numbering here for your element number 2. Okay, exactly the direction, only with plus another knot at the back. Okay, so moments will be WL squared over 12, which means it will be 4 is W, the length will be 12 meter, and divide by 12. Okay, so I think we can get it directly, 12. Okay, okay, and then Q2 knot will be getting a 48 as well, because they get they are having the same formula, and but it is in the negative. Okay, so these are all in moment. Okay, kilonewton meter. Then we can continue with WL over 2. WL over 2. So W is 12. Oops, W is 4. L is 12. Divide by 2. So you get 24 kilonewton. Similarly for 7. Okay, are you ready? So I give maybe a minute for you to sort out with this. For those who are doing it very fast, you may try to sketch, okay, your element number 3, okay? Okay, let's move to element number 3. So this is how you draw your element number 3. Okay, name your Q naught according to element number 3. This one. Okay, but now your template has a different, okay, as what you, I mean, your your loading as. So you need to be careful. Okay. So what you can do is you actually mirror this. Okay, mirror this template so that the loading acts exactly like in your beam. Okay, therefore for Q3 knot it will be MB. Okay, for Q4 knot it will be MA. Okay, similarly lah, Q7 knot will be RB, and then Q8 knot will be RA. Okay, can you follow?
Yes.
Yes,
Yes,
yes.
doctor.
Yeah, we cannot follow directly exactly A. Because the loading is opposite with our loading. So you need to also mirror, okay, this formula. So therefore, here we will have WL, Q3 knot will have WL squared over 20. But we can refer to this, the one that we have determined earlier. Okay, maybe we can get the value from there. Okay, later. Okay, but Q4 naught will be WL squared over 30. And Q7 naught will be 7WL over 20. And Q8 naught will be 3WL over 20. Again, this side is negative now. Okay. So let's get the value from your element 1. Okay. So, your Q1 node is 19.2. Sorry again. 19.2 will be here. Okay, and your Q2 node will be at 28.8. And then your 7.2 here. And another one is 16.8. Okay, so you can put in the units. Okay, now I would like you to combine all these Q naught into the Q naught vector. Okay, like this. Okay, so I'm going to gather all the information to the patch. So you can refer to your exercise, to your tutorial solution, okay, to produce the vector. It is very small. I hope you still can see. If not, refer to your page. Okay, you need to sum up all the related, like for example, Q2 node, they're happening in element 1 and 2. You need to sum them up. Okay, so you can maybe I give you a 2 to 3 minutes, 3 minutes to sort it and understand the process. Okay. Have you done? I have take you the time to also check our calculations from the Striant. I think yes, correct for element 1, correct for element 2. Okay, correct for element 3. Yes, okay, yeah. So now we need to put it in these vectors. Okay, I will delete this. So let me open it bigger. So you let me know. Okay, your solution now. Wait, this will be Q1 not will be 19.2. Q2 not will be negative 28.8 plus 48. Okay, Q3 not will be negative 48 plus 28.8. Okay, Q4 not to be negative 19.2. Q5 will be 7.2. Q6 will be 16.8 plus 24. Q7 will be 24 plus 16.8. And then Q8 will be 7.2. Okay? So Q2 not? Your answer?
19.2.
Yeah, 19.2. So how about negative 9? Yeah, negative 19.2.
2.
Okay, so this one
40.8.
40.8. So it will be same with 7 as well. Okay, so we have done for the Q naught. So if you can see that you need to familiarize with the process very well, so that without thinking so much, you can produce it. Okay, so then well done, class. Let's move to the member stiffness matrix. This is also a quite a very long process. I shall copy actually this diagram. Okay, but never mind. We will refer to this numbering. Okay, we are going to sort out for K1 first. Okay, so I think I missed out something. Oh, it's here. So this will be the template will be used. Okay, so if you still remember, we have only 4 elements that is different in this template. So the one that I circle. Okay, therefore for this we need to determine the value of these circles here. Okay, 12 EI over L cubed, 6 EI over L squared, 4 EI over L, and 2 EI over L. And the L for K1, element 1, L is 12 meter. EI is EI. Okay, constant, no value given. So this is please find your value here. Okay. For EI. Is that, I think this would be difficult to write in the matrix. Can we maintain in the fraction? Maybe it's better. Okay, do you get the value I obtained here? If yes, then you please put it in this matrix. Okay, so that okay, I will try to put it in.
Doktor,
Yes.
kan EI value kan constant, so tak boleh ke kalau just
Thank
click
you very
right?
much. EI ada di sini. Sorry ya. Yeah, you can put outside the matrix.
Okay, thank you doktor.
Yeah, you can put outside the matrix. Thank you for correcting this. There is a EI here. So now 12 EI. Oh, this is 1 over 144, 1 over 24. Oops, this is just too big for me. 144, 24. Okay, then the 4 EI is 1 over 3 negative 1 over 24, 2 EI 1 over 6. Okay, and then 12 EI 1 over 144, then negative 6, negative 1 over 24, and 4 EI is 1 over 3. Okay, so do you get this? Please check. You can do the, yeah, you can do top of the triangles. Okay, then if you require more, then you can just mirror them. Okay, please check. If you get the same thing with mine, then we will proceed. Okay, let me please be. Do you get the same placement?
Yes.
Okay, so because the EI is constant, the length is also constant. K1, K2, K3 are the same. Okay, maybe I will wait you a minute to prepare your K1, K2, K3. Sometimes I see the students, they don't write 3 times, they write only once. Okay, but make sure later you won't confuse. Okay, but for this tutorial, please make 3. Okay, 3K. Okay. Okay, while waiting you, I think I would like to copy as well for the next page. If you have done this earlier while waiting the rest, okay, you may start to give a numbering. Okay, remember you have to name this matrix nx, ny, nz, fx, fy, fz. Okay, I will show you later how, but you can try it first. Okay, so I will show on how to name the ny, nz, fy, fz. Okay, so you're referring to this element. Okay, let's say we start with k1. So we were referring to this numbering. Okay, always start with vertical ny, then nz. Okay, to naming the far end y and then far end z. So for element 1, the naming will be from 5, 1, 6, 2. Okay, so 5, 1, 6, 2. 5, 1, 6, 2. So then for element number 2, how's the naming, class?
6, 2, 7, 3.
Thank you. It'll be 6, 2, 7, 3. 6, 2, 7, 3. Okay, how about element oops, I put it wrong place. I put it the wrong place. Oops, they are all together. Okay. 5, 1, 6, 2. 5, 1, 6, 2. What is here? 6, 2, 7, 3. 6, 2, 7, 3. Then it will be 7, 3, 8, 4. 7, 3, 8, 4. Okay, so this is how you give a numbering to the member stiffness matrix. Okay, so then remember what you are doing just now is member stiffness matrix, small k. Oops, small k. If you can help me to change this to small k, not the big K. Okay. Then the next thing is to produce a structure stiffness matrix, big K. Okay, it's already in small. Okay. Before we produce the structure stiffness matrix, because in the problem they don't ask, one item like please give a complete structure stiffness matrix. Then we don't do that. Okay, so we are going to strategize our solution. I will show you this page first. Okay, an idea. You no need to write it, but this is an idea. Okay, so I should also get this. Okay, we are going to do some partition for this to explain which elements in the structure stiffness matrix that we need to obtain so that we can solve for the unknown displacement. Okay, the remaining elements in the structure stiffness matrix, the big K, you no need to determine all. We just need to determine portion, partly only. So how? So we need to know where is the unknown displacement, where is the known displacement. So just now you have partitioned them, right? It is partition in between 4 and 5. So I draw a line here. So meaning that you just need to have elements of the K for, remember this K must be square, always in the square form. So you just need to determine this region, K11 region only. Remember, we have K11, K12, K21, K22 region. Okay, so we are going to determine the elements in this 1 to 4, I mean 4 by 4 only. Okay, you no need to determine all. Okay, K12 will not be required to solve your unknown displacement because it will be multiplied with this dko equal to 0. Okay, but if you have any dk5 to 7 has value, then you need to remain. I mean, you need to also determine the column, which column will be corresponding multiplying with that dk. Okay, so but for now we only need to determine 4 by 4 only. So let's go back, okay, to our structure stiffness matrix. Means that you just need to find 1, 2, 3, 4 only. Okay, can you do it now? Okay, meaning that you need to go to column 1, row 1 to search, okay, which has column 1, row 1, for example. So if you see that only K1 has this value, okay, it will be 1/3 here. Okay, so please try it. I give you 5 minutes to do that, then we'll have a break. Okay. Have you complete?
Yes.
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 Oh, okay. You're waiting me. Okay, right. Can you give me this K12 value?
1/6.
Okay. K13 value.
0.
K14.
0.
0.
0.
Yes.
0.
K21.
1/6.
1/6.
Okay. K22.
2/3.
2/3.
K23.
1/6.
Okay, you just name it. Continues.
0.
Okay, then
0.
0.
then
1/6.
1/6.
then
2/3.
then
1/6.
1/6.
okay, then
0. 0.
yes.
1/6.
Okay.
1/3.
Okay. So is that fun? So I think this one we don't really we just follow the steps, right? Procedure, but it is quite time consuming. So we need to do the process very fast. So you can now put it in the global stiffness relations, okay, but in a smaller size, okay. You have a break of 5 minutes from now, okay. I'm going to check the attendance, okay. So make sure you have take your attendance, and we will continue solving this unknown displacement after 5 minutes from now. Oops, I think I haven't. Okay, we have two friends here, Maliana. Nadia too, are you here? Couldn't see. They are not here. Okay. So, reminder. Okay. So, how to modify this? Okay, can you come back to the tutorial?
Yes, doctor.
Okay, so you can establish your global stiffness metric in such. Okay, can you do so now while I'm filling this Q note? Wait,
Yes, doctor.
okay. Okay. You can form your, I do not know whether our calculator can solve for 4 unknowns. How about yours calculator? I know we can solve for 3, but I'm not sure whether we can solve for 4.
3 only.
3 only, right? So we need to uh, substitute something later so that it becomes 3 unknowns, so that we can put in our calculator. Okay, maybe we can write down the equation first. Okay. So we have, I will write here the equations, negative 9. How's the placement in the calculator? Let's check. This mode equation. The D must be the opposite side. X, Y, Z. Okay. So it will be, where is my pen? 19, oops, 19.2 equal to 1/3 D1 plus 1/6 D2. Oh, so, okay. So then the second equations will be negative 19.2 equal to 1/6 D1 plus 2/3 D2 plus 1/6 D3. the second. Then we move to 19.2 equal to 1/6 D2 plus 2/3 D3 plus 1/6 D4 third. Then the last one will be 19.2 equal to 1/6 D3 plus 1/3 D4. Okay, may you check? Okay. So we can actually eliminate D1. Okay, in this we have 4 unknowns here, D1 to D4. But to put in the calculator, we can eliminate one of the unknown first. And I can see that we can eliminate D1. So how we do that? We use the equation 1, okay, to find the relationship between D1 to D2 so that we can substitute that, okay, in our equation 2. So I will use equation 1 here. So it will become D1 equal to negative 19.2 minus 1/6 D2, okay, and then multiplied with 3. Okay, so I will substitute this D1 into equation 2. Okay, so it will be negative 19.2 equal to 3/6. I don't like this. Probably I will okay, never mind, we will solve it later. So D1 will be equal to negative 19.2 minus 1/6 D2, okay, plus 2/3 D2 plus 1/6 D3. Okay, then we simplified the whole things here. Okay, so it will be negative 19.2 plus, okay, you get negative 48/5 equal to negative, oops, yeah, 8. Okay, becomes 7/12 D2 plus 1/6 D3. So now this one is my 5. Okay, then I have only 3 unknowns right now. So solving equations 3, 4, 5. Okay, then you can solve for your D1, D2 to D4 first. Then only you substitute back. Okay, maybe I can put this number 6. Okay, yeah, class, do you have any questions up to here?
No, doctor.
Okay, you understand, my concern is just to eliminate one of the unknown here. So please continue this solution. Okay, I give you maybe, yeah, 3 to 5 minutes. Okay. Okay, class, do you get any answer for that?
Yes.
Is our equations correct here? I have checked, but I cannot detect anything. Maybe you can help me to check. Is that correct, the equations form here? Or the details are transferred from our Q, K, D, Q naught. Is that correct?
I think yes.
So you have checked the inputs for the equations is okay, is it? The equation form, is that okay? Have you formed the same things?
Yes, doctor.
So for those who have answered the D1 to 4, can you give me your answer? I'll put it here.
Negative
D1
46.
negative 15.36.
Negative. There are few answers, is it?
6.
Never mind, we just put on one answer here and see. Uh, maybe we can comment here. 1. I cannot hear you.
Oh, negative 15.36.
15.36. Like this. I think this is something wrong here. Yeah, now I detected. Can you help me to put in EI here? So careless. So EI. So anything that associated with the D will be having an EI. Maybe here can divide by EI. Here divide by EI. This one divide by EI. Okay. This is 200 EI. Okay. Okay. So, all right. So where shall we park the EI here? Is it here?
Yeah.
Okay, and this is EI. Okay, and this is EI. So later your information will be in terms of EI over EI. Okay, so this is you get the everyone get the D1 negative 15.36 or any other answer?
I got different, doctor.
You got what?
I got negative 46.08.
6.08. Any more other answer? Okay. Then maybe let us check again. Okay, what you need to do is you need to use the equation 3, 4,
3.
and 5.
Oh, 3, 4, 5.
Okay, are you using the 3, 4, 5? You don't need to put in the EI, no problem. Means that you just put in this value.
Yes.
Yeah, so in the calculator, this is, if not mistaken, they are putting this A, B, C, D. Okay, so there will be boxes here. So the D, we will directly get it 19.2. Let's say we are putting the equation number 3 here. Putting the equation number 4 and putting the equation number 5. Okay, so for this equation number 3, you have D1 will be your A, D2 will be your A. Okay, so it will be 1 over 6, B will be 2 over 3, C will be 1 over 6, and D will be 19.2. Is that the one? Is that like this you do? For both of these answer? Are you doing in such a way?
Yeah, I'm doing like this.
You're doing like this. Okay,
Yeah.
maybe we can continue to check. Okay, number 4 will be, we don't have D2, but we have D3, and we have D4, and we have 19.2 again. And for equation 5, we have D2, we have D3, but we don't have D4. Okay, then we have negative 48.5. Okay, can you check again? All other, may I use the Teams to see your raised hand? Okay, either you get the D1. Oh, I don't have sound anymore. Wait. Okay, I give you a minute to try again to check the D2 to D4. Need to find a solution to this.
Doctor, I got the same answer. Negative 15.36 for D1.
I'm sorry, I hear someone talking, is it?
Me,
Yeah, I'm so
I got
sorry.
negative 15.36.
Negative 15.36. Just now, the one who get the negative 46.08, are you still getting the negative 46.08?
Yes.
You still get the negative 46.08. How about D2? Maybe we start with D2
Negative
because this
23.04.
negative negative
23.04.
23.04. Okay, just now who is getting the negative 46? Your name?
Me, Nurin.
Nurin, do you get the same D2?
Yes.
Oh, okay. So how about D3?
23.04.
23.04. How about D4?
46.08.
46.08.
46.08.
Okay, so let's putting this these details into the equation 6. Equation 6 only requires D2 only. Okay, so let me check.
Okay, Doctor, I do Y.
Huh?
I tak darab 3 dah.
Oh,
I tak
3, dah darab.
yang untuk D.
So after darab 3 tu, what shall we get?
Macam Nurin.
Okay,
Same with Nurin.
okay. Okay, negative 46.08 betul?
Yes. Betul.
Oh, ada orang happy ya. Okay, so this is what we have obtained from solving this. Okay, maybe not familiar for the first time. Okay, so but we managed to solve the D1 to D4, but we haven't give them the unit. Okay, you can see that 1, 2, 3, 4. What are types of the displacement? Okay, they are all rotation. 1, 2, 3, 4. If you refer to here. Okay, so means that your unit will be in radian. Okay, just put the units here, radian. And if you get a positive value, meaning that you are actually the direction is counterclockwise. Okay, can you just put in your your direction of the, if you get a negative, means that it is clockwise. Okay, the direction. Okay, but this is not the answer for the problem given. The question asks the moment at B and moment at C. So we need to continue. Okay, can we continue with this?
Yes, Doctor.
Yes, class, no matter how, you need to solve the D1 to D4, the unknown displacement first. Then using this unknown displacement, you can solve for the support reaction and also the internal forces. But in this case, they don't ask for support reaction. Therefore, we directly solve for the moment B and C. So if you look at here, moment B and C is about element number 2. So you just take everything from information from element number 2. Okay, so oops, I don't prepare it. Okay, so means that you need to use the local stiffness equation. Okay, maybe we can write them together. Okay, but for referring to number 2. Okay, let me take the Q and key from this weight. I think I can get this and then this. Okay, K2, let us take the K2. K2. Okay, just go and the member stiffness matrix, K2. Okay, put the K2 in. Okay, don't forget about EI again here. Okay, so if you miss the EI, so it's wrong. Okay. Okay, so then the Q. Q, we were following uh, uh, this Q will be following the numbering for element number 2, which is Q 6, Q2, Q7, and Q3. Okay, following the numbering of this NY, and Z, FY, FZ. Okay, but this one is wrong. Wait, this is okay. Okay, so this one is also the numbering will be 6273. Okay, then we have the numbering of the D following exactly D6, D2, D7, and D3. Okay, and similarly for Q naught as well. Q naught will be Q6 naught, Q2 naught, Q7 naught, Q3 naught. Let us have a look on our Q naughts info. Let me go back. Okay. So okay, I'll get this. So you refer to this element number 2. Okay, I will crop it. Okay, so we will following the as well the 6 Q6 naught. Okay, is 24. Q2 naught is 48. Q7 naught is 24. Q3 naught is negative 48. All right. So now you have, no, not yet. Q6 naught, D6 is equal to 0. D7 is equal to 0. Okay, if you can see that from our calculation just now, D5 to D8 is 0. But D1 to D4 has value. But it's very messy here. We just need the D2 and D3. Okay, so D2 is this one. D2 is negative 23. Let me snap this. I worry that I cannot remember. Okay, okay, so okay, so D2 is negative 23.04 over EI. Okay, and then D3 is 23.04 over EI. Okay, and but we only want moment at B and C. Moment B and C, can you tell me is which Q? Which Q value? Q6, Q2, Q7, or Q3?
Q2 and 3.
Yes, thank you. We just need to find Q2 and 3. You no need to determine all. Okay, so meaning that I'm going to extract the formula for Q2 and also Q3. So this is how we do it. I will do the Q2 for you. Okay, so this is 24. Okay, Q2 will be equal to EI 1 over 24 multiply D6, okay, which is 0 later, plus 1 over 3 multiply D2, okay, which there is a value, minus 1 over 24 multiply D7, which is 0 as well, and then plus 1 over 6 multiply D3, okay, which has a value, okay, and then plus the Q naught 24. So then you can directly get your answer here, and it must be in kilonewton meter. Okay, so I give you 3 to 5 minutes, okay, to settle, to form equations for Q3 as well. Okay, and let me know what is your answer.
Doctor, Q naught
Okay.
for Q2 is not 24 but 48, is it? 48, right?
Q6
Okay.
naught.
Q2.
Q2 naught. Q2 naught is
Q, yes.
Q week.
48.
Okay, let me write here so that everyone can see. This is Q6 naught, Q2 naught, Q7 naught, and this is Q3 naught. Okay?
No, I mean the calculation that you write kat bawah tu. Q2 equals to EI.
Thank you very
plus
much. Correct. Yes, thank you.
Okay.
Plus 48. Okay, do you get any answer?
44.16.
Okay. Okay, I hope all of you are able to understand the process of this tutorial. Maybe we take a quite long time. Okay, so I hope practice make perfect. Okay, so I think we have solved for the answer, and then please understand also if you want to determine the support reaction, how to do that. Okay, can refer back to our example 1 and 2. Okay. Okay, class. You have any more question for me?
No, doctor.
No, doctor.
No, doctor.
Yeah, you can. Yeah, your Q2, Q3, you can be more specific, telling what is this about. For example, Q2 is actually talking about MB, and Q3 is actually talking about MC. Okay. So thank you for joining me with this tutorial session. I will share back the recorded video later to you, to your class. Okay, I see you next class. Okay, with the few more example. Okay, next class next week will be week 11. Supposed to be last week we deal with this stiffness method. Okay, week 12. Yeah, week 12 we will start with a new chapter. Okay, so therefore next week there will be maybe I will explain 3 more examples to you. Okay, on the truss, one on the truss, one on the frame, and one for the composite structure. Okay, that's all for today class. Thank you.
Thank you, doctor.
Thank you,
Thank you,
doctor.
doctor.
Thank you, doctor. Thank you, doctor.